Good evening, ladies and gentlemen. I just barely remembered that I told my students that I would do a video on this because we didn't quite get to discuss it in one of my Math 1050 classes. So, here's the video. It's 10 o'clock at night. We're going to make this a quick one. And here we go. So here's the issue at hand. We have the equation x to the fourth minus x cubed minus 2x squared minus 4x minus 24. And we're supposed to find all of the roots. And all we know is that one of the roots is x equals 2i. Now, I know we've got a glare on the board right about here. We'll do a close-up to make sure you can see everything once we're done. But here we go. Now, how do we start breaking things down if we know one of the roots is x equals 2i? Well, we're going to have to do synthetic division. Or, I mean, you can do it other ways, but synthetic division is probably the fastest way to do this problem. And so let me show you how to set it up with synthetic division. So I'm going to put my 2i in the box. All right, just like regular synthetic division, we're going to take the coefficients from our equation. So I'm going to take a 1, a negative 1, a negative 2, a negative 4, and a negative 24. Again, if there's a little bit of a glare, we'll do an extreme close-up at the end. We'll see how that goes. Okay, so synthetic division. I'm going to assume that you know how to do this. I'm going to run through it kind of quickly. Drop your 1. 1 times 2i is 2i. Now, this is where it starts to get interesting, and I'll simplify as I go. Negative 1 plus 2i is negative 1 plus 2i. Really, as far as we can go there. Okay, now we have to take this entire term and times it by 2i. So take your first term, negative 1 times 2i is simply negative 2i. 2i times 2i is positive 4i squared. All right, this is where we start to simplify. Just going to try and cram everything in. Hopefully you can see that okay. Negative 2, so here we have negative 2 minus 2i plus 4i squared. All right, so I'm going to write that out just kind of below because I'm running out of room here. Or I'll squeeze it in. We'll do an extreme close-up. So I have negative 2 minus 2i plus 4i squared. Basically just combining all the terms in this column. Let me simplify. So 4i squared is kind of like saying 4 times negative 1, also known as negative 4. So I've got a negative 2 and a negative 4 making negative 6. So this term turns into negative 6 minus 2i. Okay, now we're going to take this term and times it by 2i. So again, negative 6 times 2i is negative 12i. Negative 2 times 2i is negative 4i squared. And again, we just combine all the terms. I'm rapidly running out of room, but that's okay. I'm going to gain that room back in the next step. So I've got negative 4, negative 12i, and negative 4i squared. So I'll just cram it all in here. Negative 4, negative 12i, and negative 4i squared. Another round of simplification. I'm going to put some divider bars in between each one of these so that you can tell what is what. Okay, so negative 4i squared is kind of like saying negative 4 times negative 1, which is positive 4. So I've got my negative 4 and my positive 4 canceling each other out, and all I'm left with is negative 12i. Okay, negative 12i times 2 is negative 24i squared. All right, as you know, let me put a divider bar there. Negative 24 minus 24i squared is simply that, negative 24 minus 24i squared. As you know, negative 24i squared is kind of like saying negative 24 times negative 1, which is positive 24. So negative 24 plus 24. simplifies to 0. All right, we ready for our first extreme close-up? Here we are. Wow, getting violent. All right, here it is. Still with some glare, but at least you can see the equation, the root, the synthetic division. Okay, there's your extreme close-up. Let's do another layer of synthetic division, this time with our other root. So we've got x equals 2i. Now, let's get that back up there. How do you guys like seeing my beautiful face? There we are. How do you like that? Worn place on the wall. Not sure what happened there. We just bought the house and still figuring things out on it. Okay, we know that imaginary roots never travel alone. They will always travel in pairs. So if you have a root of positive 2i, you are also, I promise, going to have a root of negative 2i. It's just the negative version of it. So before I go to the next layer of division, let's write out the equation that we currently have. Yeah. So we have 1x cubed. Remember, we're dropping our power by 1. So 1x cubed. We have negative 1 plus 2i x squared. I'm just going to put plus signs and throw everything in parentheses. For our x term, we have a negative 6 minus 2i. And for our constant term, we simply have negative 12i. Now, I'm going to take that equation and we're going to run it through synthetic division again with our other known imaginary root, negative 2i. Now, watch the magic happen. Let's throw our coefficients in there. So we have a 1, we have a negative 1 plus 2i. We have a negative 6 minus 2i for our x term. And we have a negative 12i for our constant term. Okay, watch this. This is really cool how this works. So we're going to drop our 1. 1 times negative 2i is simply negative 2i. Okay, now we add. Negative 1 plus 0 is negative 1. 2i minus 2i is no i's. They're gone. That's kind of cool. All right, let's times. Negative 1 times negative 2i, positive 2i. All right, so I'm treating these like complex numbers where you have a real number plus a complex number. So I'm doing negative 6 plus the real number, 0, 0. Negative 6 plus 0 is negative 6. And it happened again. Negative 2i plus 2i, no i's, 0i. All right, now we times. Negative 6 times negative 2i, positive 12i. And negative 12i plus 12i is again no i's. Look at that, the magic happened, they are gone. And all I have left is this equation, x squared minus x minus 6. So here's what I know. I know that my factors are, maybe I can squeeze this in up here on the board. Our factors are x plus 2i, x minus 2i, and x squared minus x minus 6. I've just erased the first layer of synthetic division to give us some room, but here we go. If we want to break up the second piece, we have x plus 2i, x minus 2i. This breaks up into two numbers that have to add up to be -1, and multiply out to be -6. I'm thinking -3 and +2. So x minus 3, x plus 2. Now the zero product property says that I can find out my roots if I take each piece but set it equal to 0 separately. So imagine taking each one of these pieces, x plus 2i equals 0, and setting them equal to 0 separately. So x minus 2i equals 0, x minus 3 equals 0, and x plus 2 equals 0. All right. Pretty easy to solve from here. Our roots, finally, are x equals -2i. Remember, just subtracting 2i from both sides. X equals +2i. X equals +3. And x equals -2. And there we have it. See, just like magic, you can use synthetic division, although it gets a little bit messy for that first step, to find all of the rational and irrational or imaginary roots of any polynomial. That's going to do it. I hope this has helped you out. Let's do one more extreme close-up to make sure we've got everything. All right, extreme close-up here. Here's your factorization. Here's your second layer of synthetic division. Everything, all of those imaginary numbers canceling out. Isn't that beautiful? All right. All right, ladies and gentlemen. If that was too quick, let me know. Leave some questions in the comments below. I'll help you out to the best of my ability. I'm going to edit this video and go to bed. Good night.